The other thing we've had is so-called gravitational wave detections. So these are colliding black holes, and they collide and merge together. And obviously that's quite a violent event in the universe. And so that event, that process ripples space-time. So it sends ripples out in the fabric of the universe, space and time. And actually Kip Thorne is I've spoken to him several times. He's one of the greats, right? Won the Nobel Prize for this. And he calls it a storm in time. So you get a time storm. So really, we're to think, as we speak now, there will be these very tiny ripples from violent cosmic events passing through this room. And they're changing the rate that time passes. So that as they go through. And we can detect that now. So we have detectors that can pick that up. And so we've seen those collisions as well.
So these collisions, how far away?
Oh, millions of light years away.
And they're affecting what's happening in this room right now?
Yeah, to a tiny extent. So there's an experiment called LIGO, which is the, what it stands for, something like gravitational interferometer. I can't remember exactly what but so basically it's laser beams. And there's one in Washington State, north of Seattle, and one in Louisiana. And they're kind of laser beams, 4-kilometer long laser beams at right angles. And they can detect these very tiny shifts in the, effectively, you could say the length of the laser beam. It's a bit more fiddly and complicated, but it essentially measures the distortion in space-time caused by these ripples. And it's way less than the diameter of an atomic nucleus, by the way, way less. These little sort of...
Oh, my God.
And so we've observed many of those collisions. There it is. There's LIGO. So it's just basically 2 laser beams but with these ultra high precision thing. And so we've got data now of the collision of black holes and those event horizon pictures with radio telescopes. So that's part of it.